Here we go with my work solutions to the OCR paper. As you can see, it's the summer of 2024. It's the third and final paper on the higher tier, which they call paper 6, which you call the second calc paper. So let's shut up and get on with it. Matching up some graphs, but so waffly, it's unbelievable. At the end of the day, when you look at this one, it's direct proportion. So it's a straight line graph upwards. All right, positive gradient. But because there is a position there, that's why that relates to graph 2 and not graph 1. Graph 1 is actually the bottom one, because if something has a zero mass, it has zero volume. At the end of the day, they are related by a multiplier, so it would be of the form y equals kx, because it's from there that you can derive your density mass volume triangle. But anyway, average speed when running 200 meters. The reason why that's graph 5, think about it, it's not possible. Every extra bit of speed you do will bring your time down slightly, but it will never be zero. So it's one of those graphs that approaches zero, but will never reach it, which, as we know, disqualifies and disqualifies, but it certainly is not a case of going like that. What the heck's happening up here? You can't run that fast, and so on, which you could argue is here, but no one runs the 100 meters in 1 second. It's more like over there. Anyway, it's graph 5, trust me. Number 2, I always write them out fully on my PDF, on my worked answers. Here on my videos, I just read through them. If you want the real worked answers that I would submit to an examiner, look at the link in the bottom of the video, go to my website page, and you'll see it. There's sort of a family of 4 links. There's the paper itself, clean, the mark scheme, the worked answers, and the link to this video that you're listening to right now. Anyway, give 2 reasons why this graph is misleading. There are no labels on the y-axis, and that's a year, that's a year, that's quarters of years. The x-axis has uneven spacing, all words to that effect, for reason 2. Number 3, more waffle than there needs to be. All we care about is the chance of pulling out an M tile is 2 out of 11. 99 children are doing it. We multiply by 99 to find our expected value. Calc says 18, and we obviously go with that. Number 4, again with the waffle. They're really loving it. The key step, if you want to go from centimetres to kilometres, it's a multiplier of 150. Heidi measures accurately 5 centimetres for her charity walk. Straight away, get your 5 times 150. She's reckoning she'll be walking 750 kilometres. She thinks she can do 2.5 kilometres per hour for 10 hours. That means she's thinking she can walk 25 kilometres per day. How do we do a rough calculation? A divide. Total distance divided by how much she can do per day tells us that she thinks it will take 30 days. But she hasn't considered your likely answer to part I. 2 ways of going about this. One is she's measured it in a straight line. There'll be no such road. There'll be left turns, right turns, and turns which don't go in the right direction perfectly. And close. So anything where she goes, where you say the true journey should be more than 750. All right, so that's one way. The other one, surely she's going to get a little bit slower. Feet are going to start hurting. So towards the end, she might not be doing 25 a day, might be slowing down to whatever. Yoshi writes the scale of the map as the ratio of 1 to 150. Now you can use a lot of waffle. Yoshi's error is he's used inconsistent units, because 1 to 150 is like for like, centimetres to centimetres, metres to metres. That's not what it should be. If you want to write it as like for like, you must turn kilometres into metres by timesing by 1,000. Probably should have put it down here because it is the answer. And then from metres into centimetres, times it by 100. So there, whoops, need an extra naught on because it was times by. There we go. Because it was 150 kilometres to begin with. For some reason, my brain switched to 15. Anyway, on we go. For number 5, we've got 10 congruent right angles. So I've done a little bit of marking, as you can see. You could, if you wanted to, use a bit of trigonometry on there or whatever. But really, the best way to go about it is angles around a point is 360. So each one there, that angle where they meet in the centre is 36. Meaning, if you want to use that angle, it's 54. But one thing we also know is the base is 6. Logic, how do you find the area of a triangle like this? Half base times height. We're going to need to do the area of the whole. There's 10 of them. And we're going to be timesing by a half. The base is 6. We just need the height. I never use the letter H for height because just in case, as in this case, it's not the hypotenuse. We've got to find the opposite to give us the height. We've got the adjacent. It's a TOA, and we want opposite. It's tan of 54. Close your brackets if your calc is one of them. Times it by 6, which gives you 8.258-ish. And when you slap the final bit in your calc, you know what you're aiming for, and I get 247.748-ish. In other words, 247.75. Part B. Definitely one of those with evidence that just because you can't do Part A doesn't mean you can't do Part B. Part B might look waffly wordy and whatever. Trust me, it's easier. You're told the pyramid has volume 450 and you're given the formula. Just get on with it. The volume of the pyramid is a third times the area of the base. That's why they gave it you in Part A. So even if you didn't smash it, you can still use it. Multiplied by the perpendicular height, well, it's called H in there. Grab your calc, work backwards. Start with 450, times by 3, divide by 247.75, and out pops a very reasonable looking answer of 5.45. 6A, as I've been doing more tutoring, it definitely is a case that, certainly in the schools local to me, they are preferring Venn diagrams for HCF and LCM. We don't need the box round it because they're all going to be involved. In the A and the B, there's a 2 and there's a 7, leaving the A with a 3 and another 7, leaving the B, if a 2 and a 7 are used, it's got 2 2s left over. And if you wanted the HCF, it's 14 because you multiply the numbers in the middle. We want the LCM, so you times the whole lot. Calcs at the ready. for 1,176. Part B, another example that it looks hard once you get the gist of it. Do a factor tree for 26. It's about as simple as it gets. For highest common factor, you'd want an overlap, an intersection. We haven't got one, unless k is 13. That's it, folks, because k is 13. Number 7, loads of waffle. 2 bags. Bag X has 5 to 7. Bag Y has 5/12 of. This is one of the key understandings. Just because things are given in ratios or proportions doesn't mean these haven't been simplified. Show how you decided. Something like bag X could be 10 to 14, as in you double them both. There could be 10 apples, 7 bananas, and that simplifies to 5 to 7. It could be 500 to 700, but you give some examples. Okay, the fact is bag X could be 10 to 14. I'd write something else saying each of them are just given in their simplest form. They might look identical. Now, there is a case. There could be 5 and 7. And in bag Y, that would also therefore be 5 and 7. So it's the middle one, because there is one case that Finley is correct, but I've just given an example, 10, 14, 50, 70, whatever you want to do. But that will get you the marks for arguing that things can cancel down in proportion. Part B, loads of ways of going about this. You can brute force it. What I mean by that is, you've got the ratio of 5 to 7. Keep adding on 5 and 7. Keep going. Calc if you need it. And 11 and 14. Ultimately, you will get to the right answer. It's 56 and 40, I believe. All right, something like that. But I don't care. It's 56 and something. Because this one works for brute force, but what happens if the answer was much bigger? You're going to be there all day. So my argument is, bag X started with a multiple of 5 apples and a multiple of 7 bananas. We added 4 apples. We didn't add 4 bananas. And the idea with ratios, turning them into proportion, is that the amount of apples, which is 5x plus 4, out of the total amount of apples, which is 12x plus 4, will equal that proportion there. And we're talking about apples, so it's 11 out of 25. Now, I know people are going to say it looks more complicated, but don't forget this way always works, even if X was like 100,000, because you'd be there all day trying to brute force it. Let's times both sides by 25. Let's take that up to the top and expand it by 11. 132x, 11 fours are 44. We are going to subtract 125x from both sides and 44 from both sides. You could work out, therefore, that x is 8. But we don't care. How many bananas are in bag X? 7x, which is worth 56. I know that that weighs a bit longer, but it always works. 8a, you've got a calculator, use it carefully when you are subbing in a minus, use some brackets. Hopefully you get -4 and 0, just like me. I don't obviously trust myself to be able to draw that with an electronic pen, so I've cut and pasted it from my worked answers. Hopefully yours is pretty decent as well. You're allowed a bit of leeway. All right, you're allowed some wobbles, a bit of feathering here and there, but ultimately do make sure it never goes straight, it doesn't curl back on itself, and you get as close to the X's that you've marked as possible. Part C, this will explain equals to 5. That's why I've put this line on, because it's equal to 5 there. Reading off my answer, I get 3.4. There's no specific answer on the mark scheme. They just say allow the follow through from your graph. So make sure you've drawn your line on, because it counts as part of your working out. Number 9. Show that the area of the sector. So it's kind of saying, don't worry about the parallelogram just yet. Do the area of the sector. Area of a sector is pi times the radius squared, because that's the formula for a circle, and it's multiplied by the angle out of 360. You might have used a 12th there. It's all good. Calc will probably spit out 12 pi, which is 37.699 as a decimal, which is 37.7 as required. Work out the percentage of the parallelogram that is not shaded. Well, first job, we need the area of the parallelogram. That is base times height. 20 times the 6. Easier than you might have thought. So what percentage is not shaded? Well, the amount which is not shaded is 120 minus the sector. That's how much is shaded. You divide it by the total amount of area, times it by 100. Calc gives me 68.58. I'll call it 68.6. Mark scheme allows anything between 68.5 and 68.6. Onwards. Number 8. Firstly, it's almost quite laughable. Got to be honest. Add up the top numbers, you get 42. Add up the bottoms, 26. Take them away, it's 16. Can I get on with the rest of my life now, please? Thank you very much. Part B is pain in the backside algebra. Use algebra to prove that for any set. So the idea is, call that x. This will be x plus 1, x plus 2, x plus 3, x plus 4, plus 5, plus 6, plus 7. And yep, you've got to do it all. I did it this way. The top will be the x plus 1, the x plus 2, and the x plus 3 simplifies 4x plus 6. And along the bottom, carry on from there. It's x plus 4, x plus 5, x plus 6, and x plus 7, which simplifies to 4x plus 22. It says find the difference is always 16. Best way of finding the difference is do biggest, take away the smallest, and bosh, what a waste of time. Number 13. I don't bother reading that question. It's a frequency tree. I map it back. 13 plus 6 means 19 were on time. 5 plus 4, 9 were late. And add them together means 28 things in total. Find the relative frequency. If you're not sure about that, it just means fraction. It basically means probability, but just in a context. no seats. That's 6 plus 4, 10 out of the 28 journeys. Don't bother cancelling it down. Doesn't ask you to. Jack says if the train is late, travellers are less likely to find seats available. We look at the diagram. If the train is late, 5 out of 9 seats are available. That's 0.5 recurring. If it's on time, it's 13 out of 19. That is bigger. That is 0.68. So the proportion is bigger. That's a yes. Does Jack's data suggest he is correct? Yes, it does suggest it, because 0.68 is bigger than 0.5 recurring. All words and waffle to that extent. Number 12. Solid lines will always have the equals part on the inequalities. Dotted lines don't. Be careful with that. You've already been told one of them. We've got this other line, 2x something. It's below. So we need the y, the height, to be under, but because it's a solid line, should be equals. This vertical line here, that's of the form x equals 2, but we are looking at left. That's where x is underneath or smaller than 2. It's a dotted line, so we leave it alone. There's no equals 2 there. Take care. Number 13 for some histograms. Students took 5 minutes to travel. 16 students, are in there. That has a width of 5. We haven't got a clue about the height, the frequency density scale, but we can find it out. Area of this bar is 16. Width of the bar is 5. The divide tells us the height of the bar, making that 3, that 2, and that 1. How many students took less than 20 minutes? Well, we already know 16 of them did. Now what about this one? Its width is 5, its height is 2. In we go. What about this one? Its width is 10, its height is 1.4. There's 14. We have our total. 40 students. 9 students took, there's 9 in this section here. So the area of this rectangle, which we need to draw, is 9. Its width is 15. To work out its height, you need to do area 9. 9 divided by 15 should give you 0.6. And there we go. Hope I make a decent job of that. Not the best. I'm sure yours will be a lot better. Number 14. You've got a distance. It's quite a strange one, this. What I did to picture it is this. You've got this distance of 10 or this distance going on over here. The distance from the point 0, 10 to the point 12 along, in other words, the line I've just drawn is 12, but there's 2 possible places where T is. It could be up here, it could be down there. At the end of the day, that distance is 12. The distance is 12.5. Let's use a bit of Pythagoras. X is going to be the hypotenuse squared minus the shorter side squared, all square rooted. We get 3.5. That's not the answer. x being 3.5 means the possible value of t is, don't forget that coordinate is 12 along, 10 up. That's where that is. So we need to add 3.5 on and subtract 3.5 away. So the actual answer's 6.5 and 13.5. On we go. Question 15 got a pretty straightforward inverse proportion. Follow the rules. Y equals a constant. Inverse means over x cubed. You've started. Stick in the numbers you know. Y is 4. When x is 12, 12 cubed on my calc, 1728. Multiply both sides by 1728. You've got your value of c. That needs to go back in. And that's your formula. That's all you need to do. X cubed. Number 16, laws of indices. Deal with the numbers first. The 9 times the 2 on top is 18, divided by the 3 on the bottom is 6. Next bit of knowledge required. Root means power of a half. Calculators at the ready so you can just speed up the fractions. We need a number. We need a power. How do we get it? On your calc, 7. When we multiply, we add the half. When we divide, we subtract the 4. Done. 7 over 2 or 3.5. On we go. Into question 17. Might be a calc paper, but they're obviously writing it in bold, so you'd best do as you're told. Show that. That's the old let x equal whatever you've been given. And do what you need to move them up so that the digits after the decimal points are the same. That is done by multiplying by 100. So now when you subtract them, bottom take away top, you get 99x, 18.18 recurring minus all the recurring bit, just leaves you with the 18. Then divide by the number next to x, in this case 99, and they're all in the 9 times table. Divide by 9, keeping one eye on the answer, and you're home and dry. Part B, explain. Well, the first thing to explain is it's 5 times bigger. So make some note that to go from 2/11 to 10/11, it's 5 times the size. Once you've done that, take your 0.18 and maybe go a couple more decimal places. Or if you really want to, go a few more and just times it by 5. Pick any of them. They're all good, but guess what you get? 0.9090. If you do this, yeah, you've guessed it, 909090, you've got enough. Well, helps if you put the naught in. 0.9090. Another way of thinking about it is, and how else do you times by 5? You can times by 10, which budges them up to 1.81818. And what does 18, as in 18, halve to get? 9. So do it by, so in other words, you can times by 5 by timesing by 10 and then halving. However you get there, it's all good for the 2 marks. Number 18, typical trigonometry question, always going to involve sine rule or cosine rule. The key to them always, look at the side which they share. That's the key to the question. Calculate the length AD, slap an X on it. So that's definitely going to be the second triangle. We need to work on the first triangle and find the length of AC. We only have a side and the angle opposite. It's a sine rule question. The length A to C divided by the sine of the angle opposite is equal to the length of AB, 8, divided by the sine of the angle opposite. And you've got various ways of rearranging them. I'm sure some teachers just go times both sides by sine 60. Certainly is the easiest and the quickest. However you rearrange it, you should get 20.2567 whatever. You've now got that. How do we find x? Well, you've got A to C and C to D. They are the sides, either side of the angle that's 55. So part 2 of this question, it's a cosine rule question. We can say that AD, which is x squared, equals b squared plus c squared, but just we're ignoring the labels. It's 6 squared plus the 20.2, that looks like a B, I know. OCD kicking in. 6 squared added to 20.2567 squared minus 2 times the 6 times the 20.25. I just use the A and S button on my calculator, multiplied by the cos of the angle between them. Stick that right hand side into your calculator, and wherever you get should be 306-ish. 306.908 I got. You need to square root it to get the answer, 17.518. To a sense, and so on. To a sensible degree of accuracy, I'm going for 17.52. Mark scheme allows anything from 17.5 to 17.6 inclusive. Next, you've got a circle. When you've got a circle, it means you have a radius. It goes from 0, 0 to 12 minus 5. First thing to look at, find the gradient of the radius. The gradient of the radius is the vertical change, which is 5, divided by the horizontal change, which is 12. Not forgetting the line is downhill. It might not be drawn to scale, but it can't be drawn to lie to you. It has to be a negative gradient. That means the gradient of the tangent is the negative reciprocal. Flip it upside down and change your minus to a plus. So this line we've got, we can now find its equation, because we have a y coordinate, negative 5, an x coordinate, which is 12, a gradient, which is 12/5. They're multiplied, and now you reach for your calculator, because C is going to be negative 5, take away 144/5. You get the horrible looking but correct negative 169/5. That means you've got the equation y equals mx plus c. You know the m and you know the c. Where is the coordinate p? P is on the x-axis. So when we go for y equals mx plus c again, we can replace the y coordinate with 0. The m, that's the gradient of this tangent, that's 12/5. the x coordinate is denoted by the letter P, minus the 169 over 5. You can times through by 5, 0 times 5, who cares? And you find P, you add 169 to both sides, and you divide both sides by 12. Job's a good one. On we go. Number 20. Oh, it's the last question, actually. If you wanted to, I know there'll be some people who straight away write the 4 as 4 over the same brackets. Bit of patience. Leave the 4 alone for now, because it will get simpler. When you factorise the top, that's our old friend, difference of 2 squares, 49, sorry, minus 49, it's a square number, so it's plus 7 and minus 7. And hey presto, it's about to get a whole lot simpler. So, to combine these as a single fraction, it would be nice if the 4 was over an x minus 3. Well, it is now. We simply have written x minus 3 over x minus 3, which is a stupid way of writing the number 1. Added to x minus 7 all over x minus 3. And now we can write them all over the same denominator of x minus 3. And at the same time, let's now expand. Plus x plus negative 7. And we're there now. We just need to simplify. Numerator is 4x plus x. Negative 12, take away 7, down to minus 19. Over x minus 3. Nothing simplifies more than that. We are done. We've made it to the end of all 3 papers. Hope that's helped. Papers 4, 5 and 6. I think I've got 23 to do next. Loads of fun. So yeah, not the worst papers of the world. OCR definitely on the wordier side of all the exams, but don't let the words put you off. Stick with the process, follow the methods that you know. If it works with numbers, it works for letters. Stuff will cancel out. Overall, not the worst papers in the world. Get your teeth into as many questions as you can. Don't give up. Hope it's helped. See you on the next one.